When a polynomial can't be factored using known methods, we're going to use something called the factor theorem. For example, if we take a look at this looks like it would be excellent for grouping. So I'm going to pull out an x squared, and I'm going to get x plus 1. And then here I'm going to pull out a negative 4, and I'm going to get 2x plus 3. It does not match up. These are not similar parentheses. We can't factor this by grouping. So what we're going to do is we're going to use something called the factor theorem. And what they're saying is x minus b is a factor of your polynomial if and only if p of b equals 0. This means that if you plug in b into the function, you will get 0. Now, I do want you to note that the leading coefficient in this particular thing is 1. So now, we're going to use our function p of x equals x cubed plus x squared minus 8x minus 12. And what we're going to do is we're going to find all of the factors of negative 12. We're going to write these down. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus, 4, we forgot, and plus or minus 12. So many different factors that we would need to do. There's 24 things to check. There is a short way using our calculator that we can use it. But we're going to see how we would do it the long way. What we would now do is we would take these possible roots and we would start trying to see which one worked. So we're going to take this p of 1. We're going to say, what would happen if I plugged 1 into this function? And I would get 1 cubed plus 1 squared minus 8 minus 12. I don't even need to know what this equals, but I do know that it doesn't equal 0. So it's over. So that means x minus 1 is not a factor. Now sometimes you can eyeball it and see what sorts of things would work. So I'm going to check out negative 1. If I plug that in, I get negative 1 cubed is negative 1 plus 1. Negative 1 times negative 8 is plus 8, and then minus 12. So we get a 0 here with these two. But 8 minus 12 is still not 0. So again, x minus negative 1 is not a factor. So now it's x plus 1. You can know that you don't want to plug in 12 because 12 cubed plus 12 squared is way too huge to actually have it equal 0 when you subtract 8x minus 12. So what we're going to do is we're going to cut right to the chase, and we're going to try negative 2. If we plug in negative 2, we're going to get negative 8, then we're going to get plus 4, plus 16, and minus 12. And when we do this, this equals negative 4, and this equals positive 4. So this whole thing does equal 0. So what that means is that x minus a negative 2, which really is just x plus 2, is a factor. So we know that this whole mess is equal to x plus 2 times some other stuff. The way to find the missing stuff is to now use log or synthetic division. So here's our function again, right here. And we're going to use x minus, and since it was a negative 2, we do that. Or we just put our negative 2 in here. I'm going to use synthetic division because we need to move this video along. Negative 2 times 1 is negative 2. Add. Negative 2 times negative 1 is positive 2. Add. Negative 2 times negative 6 is positive 12. Add. The remainder is 0, as it should be. If it's not, you either made a mistake or you really don't have one of the factors. So this is x squared minus x minus 6. And I'm going to put it up here. X squared minus x minus 6. What does this whole mess mean? Well, what it means is that p of x, this big function that we saw in the beginning, it is the same thing as x plus 2 times x squared minus x minus 6. This is how it factors. What you need to ask yourself is, can it be factored again? And are there two things that multiply to give you 6 and subtract to give you 1. And it's 2 and 3. So we would want to continue factoring. This next set of parentheses, it's got a 2 and a 3 in it, and it's a minus 3 and a plus 2. So now it's fully factored. But what happens when your leading coefficient is not 1? Of course, it's more of a mess. So what we're going to do is, because the leading coefficient is not 1 in this particular problem, we're going to use something called the rational, you can abbreviate it like that, rational root theorem. And this is what it is. The rational root theorem says that ax minus b, so something in front of the x minus another number, is a factor of your polynomial if, when you plug in b over a, it equals 0. So we're going to see how this works, and we're going to show you the shortcut. Again, this does not factor by grouping. So what we're going to do is we're going to write down what the possible roots are. You're going to get your b's from here, just like we did. So we're going to write down all the factors of negative 3. So we're going to write plus or minus 1 and plus or minus 3. Then we're going to get our a's from over here. So what you're going to do is we're going to, since it's positive, mercifully, we just have 1 or 2. Those are the only factors of 2. To get the possible roots, we're going to put the numbers that are on top over the numbers on the bottom. So I'm going to start with positive 1. The possible roots would be 1 over 1, all right, and negative 1 over 1. We would also have 3 over 1, and I'll write it this way so you know what I'm actually doing. We would also have negative 3 over 1. Then we would have, I'm going to do 1 over 2. So I'm going to have positive 1 over 2 and negative 1 over 2. And we're going to have positive 3 over 2 and negative 3 over 2. Most of us have better things to do with our lives than plug all of these numbers in to keep trying. So what you can do is we can use our calculator to narrow this down. And what we're going to do is we're going to enter it in graph, and B, we're going to find the zeros. Now if you remember, zeros, roots, all of these things are fancy names for x-intercepts. So you can just find where the graph crosses the x-axis. So we're going to go, and I want you to hit pause, and I want you to enter this function up here into your graphing calculator now. So take a moment and get that entered into your graphing calculator. When you hit graph, you should get something similar to this. Here's our graph. What we're going to do now is we're going to look and see where does it cross the x-axis. Well, none of those negative options, it doesn't cross there at all. It only crosses right here at this point, and this point is between 1 and 2. So we're going to go back to our possible roots, and are any of these between 1 and 2? And 3/2 is 1 1/2. So we're going to plug that into our problem. So we're going to try 3 over 2. And when you do that, you're going to get 2 times, and I'm going to cube this already. We're going to get 27 over 8. Then we're going to get minus x squared, which is going to be 9 over 4. And then minus 3/2, and then minus 3. You could enter this all into your calculator, and you would find that it equals 0. So, if 3/2 is the root, what did the original parentheses look like? And it's 2x minus 3. That's the factor. So what you want to do is the number on the bottom, this gets attached to the x, and this number on top is the b part of the variable, the b. And it's always the opposite of what your root is. If your root is positive, you have a subtraction sign. If your root is negative, it has an addition sign. So what do? A, find the root. B, use that factor to do some long or synthetic division. We're stuck with long division right now. I'm going to have you hit pause, try it out, and in 5 seconds this will reveal itself. We get x squared plus x plus 1. So, all that work, that horrible little function, 2x cubed, this whole thing, it factors to be 2x minus 3. That's the first factor we found. And then by long division, we found the other part of it. And can it be factored again? What two things multiply to give you 1 and add to give you 1? Nothing. So we are finished with this particular problem. There is one last note, though, that I do want you to know about. We are not going to encounter this, but it does happen. If none of your possible roots yielded a 0, if you plugged in all your possible roots and none of them worked out, you couldn't find them in a table, you didn't see any of them on the graph, if none of them yields a 0, then it means that p of x has no linear factors with integer coefficients. So it means that you couldn't just factor it. It might factor using nasty square roots or something horrible. So bring these questions, if you still are having trouble understanding this, bring these questions to class, and we'll see you in the morning.